Hello and welcome to the Learn via elearn.com classes. So in today's class we will see a very fresh new topic which is called as a threaded binary tree. Alright, so we will cover about what is threaded binary tree. We will also see in order travels, which is not exactly part of this threaded binary tree, but yes, we require this to understand the threaded binary tree. So we will cover this topic also. Alright, we will also see types of threaded binary tree. Alright, and then advantages and disadvantages of threaded binary tree. Alright, so let's get started with our basic graph. Let me make it quickly. For example, I'm going to make a graph here of a normal binary tree. This is some vertices. For example, this is my A, B, C, then D or E, then we have F, then G, then H, then I and J. Alright, so let me before that let me make it in a circle also, so that this looks like a graph at least. Okay, so okay, now let me connect it. So connection would be like in this way. Okay, this is E is connected with H, for example, and these are connected with this. Right, team, if I see the last node of this graph, for example, if I say H, there is no as such further leaf, right? So if I say, for example, if I'm going to connect this node with his previous node somehow, if I'm going to connect, so for that I need to make a thread, right? If I connect this node somehow to his previous node or is some parental node, then if it's on the left side, then it's called as in order predecessors, and if it's going to be connect towards the right side, then it's called a successor. Okay, so before going further, let me draw a basic structure of the node which I am going to make in this threaded binary tree. For example, this is a, a basic layout of a H node, for example. Okay, and these are two parts which I used to call as a left child and a right child. Okay, let me write down here. This is, for example, my left child. Okay, this is my right child. Okay, now if I consider there are two virtual threads, or there are two threads through which I am going to connect my left predecessors and our successors, or I can say the in order predecessors and successors, right? So this is my left thread. Okay, and this is my right thread. Now in threaded binary tree, we use these left and right thread to connect his in order predecessors and successors. How? We will see. Alright, so to connect this, first of all we need to write the sequence of the node in order traversal format. Alright, So what is in order traversal format? We will see. For example, let me write it. In order traversal. It's not on, this is in order traversal, right? So first part is the basic rule of this in order traversal is, first of all we need to traverse towards the left subtree. Alright, so first of all we need to find the leftmost subtree, and we will move towards the leftmost part of the vertex, okay, or the leftmost part of the node, right? And then after visiting this left one, we will visit the root, visit the root, and if required, then we will move further towards, if there is any further left or right subtree. Otherwise we will traverse the right subtree, okay. Okay, so these are some basic three key rules which we need to follow whenever we are going to traverse the in order traversal. Alright, so let's try to traverse in order fashion in this graph. So the leftmost part of the of this tree is this BDEF, right? And under which we have